Hello folks, and pagi teknik. Having a proper sanitation facilities is a right for all human beings. Thus, has it been really fully implemented? Hi, we are Group 10, and through this video we will evaluate and explain our design of wastewater treatment plant in FMIPA UI. Sit back and relax, hope you will enjoy our video. Before we are going to start to talk about our design, first we are going to talk about FMIPA UI itself. Firstly, FMIPA UI is located in Jalan Prof. Dr. Sujono D. Pusponegoro, Campus UI Depok. As the second most populated faculty, FMIPA UI's population consists of students, lecturers, and other staff. In 2020 itself, the total number reached around 4,000 people and is projected to increase until it reaches its maximum capacity. There are 15 buildings in FMIPA UI, consist of lecturer buildings, laboratories, cafeterias, praying facilities, and multifunctional hall. Next, we are going to talk about its wastewater generation. Based on our population's projection and assuming that the generation of clean water usage is 80 liters per capita per day, the total clean water usage is around 400,000 liters every day. And around 80% of clean water usage and the addition of infiltration water combines into FMIPA wastewater, which is around 300,000 liters per day or 383 cubic meter per day. Due to intense and diverse activities, the generated wastewater have characteristics as follows. And then the whys. The FMIPA UI's wastewater treatment plant is planned to support the activities of FMIPA residents, which are projected to increase, whilst also considering the presence of wastewater produced from the cafeterias and other buildings with poor treatment. So, let's talk about our design recommendation. Our proposed wastewater treatment plan are planned based on this flowchart. Every unit are carefully selected based on several considerations such as pollutant load, processing efficiency, ease of operation, energy requirements, and costs. The system begins with grease trap, which will receiving wastewater from cafeterias, and it moves to equalization tank, primary sedimentation tank, membrane bioreactor, and it will be released into Danau FMIPA UI. We also designed the sludge treatment process, which consisting blending tank, holding tank, and filter press. There is also a shelter for officer who are responsible in operating the system. The area of the treatment plants is 340 square meters, with its elevation is 67 meters above the sea level. First one is grease trap. A concrete-based grease trap serves to prevent oil and fat which came from the cafeteria's waste flow within the wastewater, while wastewater from the other sources will continue to flow to the next unit, with as shown in the picture, fat being deposited at the bottom of the tub and the effluent flows onto the effluent pipe. This unit is planned to be located 2.4 meters under the ground. Next, equalization tank, which is a unit that stabilizes the water flow and its temperature before being pumped to the water treatment unit. Starting from the influent box, the wastewater is stored inside the 4-meter depth tank, collected and pumped through the effluent pipe with uniform flows. The wastewater will enter the sedimentation tank. As the name suggests, a sedimentation tank functions to form sediment by allowing solids to settle by gravity to the bottom of the tank, which then routinely swept by a flight scraper into the sludge hopper or an effluent hole for the sludge. The last unit is a biological treatment unit. Membrane bioreactor, or MBR, is a biological treatment unit that has a high efficiency level, which operates through diffuse aeration system and utilizes membrane components to capture biological pollutants. In short, it filters the water. The advantage of MBR is it is a compact treatment which does not require a secondary sedimentation tank and can replace the role of a disinfection unit to inactivate the coliforms and does not require a large amount of space, which is a really good choice for a compact wastewater treatment plant. And what do we do about the generated sludge? The remaining sludge that are produced from the sedimentation tank and biological treatment tank are then treated before being distributed to third parties, processed in a blending tank, stored in a sludge holding tank, and dried using a belt filler press so that it can reduce its mass by up to 80%. These processes aim to fasten the sludge drying time and lighten it to achieve cheaper transportation costs. Why do we choose MBR? Because it has a high quality effluent, less sludge production, and potential for simultaneous nitrification or denitrification in long SRTs. Its high removal performance eliminates the need for a secondary clarifier and disinfection unit. And so, what's the good part about our design? Well, the wastewater treatment plant will be located far away from FMIPA's main building, utilizing gravity to drain wastewater, and ensuring compact wastewater treatment design, which means less area are needed. Taking account as a consideration, we have estimated the total construction cost, which is around 2 billion rupiah or 6 million rupiah for 1 cubic meter per day for 5 years. The conclusion that can be drawn are: the proposed wastewater treatment plant area of FMIPA UI is 340 square meters with an elevation of 67 meters above the sea level. The quality of the effluent that has gone through the plant wastewater treatment will be below the maximum limit of the wastewater quality standard, which is Permen LH nomor 68 tahun 2016 and PP nomor 22 tahun 2021. The treatment consists of grease trap, equalization tank, primary sedimentation tank, and membrane bioreactor, and also there are sludge treatment too. The estimated cost required to build a FMIPA wastewater treatment plant is 6.5 million for 1 cubic meter per day. With that being said, it's all wrapped up. We do hope to witness the realization of this wastewater treatment plant project. Hope you guys enjoy our video. Thank you.